Eighth grade math lesson 5.3 is linear relationships and bivariate data. Don't let that word scare you. It just means bi means two, variate means variables, and all along you've been dealing with the two variables x, y. So you're going to find this lesson very, very similar to what we've been doing. So you should feel confident going into this. You've got all the foundational skills that this should be fairly easy for you. So let's just jump right in. Example 1 talks about a handrail that runs along a stairway. As the horizontal distance from the bottom of the stairway changes, the height of the handrail changes. Show that the relationship is linear, that it creates a line, and then find the equation for the relationship. They plotted them for us. 5 on the x turn, go 7 on the y. 10 on the x turn, go 11 on the y. 15 on the x turn, go 15 on the y. And so they plotted all those for us. I can show that it's linear by simply connecting the dots, and ta-da, it's a line. But also, if I wasn't sure if it might look like there's a slight curve there, I could use the slope formula on 2 points and then compare it to the slope formula on 2 other points. And if they come out with the same answer, ta-da, it's a line. So that's how I would do that first step to create or to show that it's linear. Now I'm just going to go ahead and take my skills and find out what is my slope and what is my y-intercept so that I have it written in y equals mx plus b format, the slope-intercept form. So let's go ahead and get started with that. So to find the slope, I could, if I had really precise points, just find the rise and the run, and that would be my, and reduce it, and that would be my slope. Rise would be over my run as a fraction, and that would be my slope. I don't have super precise points that are easy for me to find. I do have these numbers there, so I'll just use them in the slope formula. M equals y2 minus y1 over x2 minus x1 is pretty quick to calculate. I'm going to choose 2 points. I'm going to choose my lowest 2 points right here. The 5 on the x, 7 on the y, and the 10 on the x, and 11 on the y. These are my x's, these are my y's, this is my first choice, this is my second choice. So that would be y2, y1, x of my second choice here, x of my first choice there, x2, x1. I'm just going to plug in those numbers now. So my y2 is 11 minus y1, which is 7, over x2 minus x1, x of my second choice, 10 minus x of my first choice, 5. (11 minus 7 is 4. 10 minus 5 is 5. So I get the equation of y equals 4/5 x plus b. Y-intercept being where it crosses that y-axis. Hard to tell though because it's really in between, and so I'm not sure if it's a decimal or not. So when that happens, I might just to be sure choose an x and a y, plug them in for x and y, and then just solve for b. So substitute the x and y here into the equation, solve for b. So I've done that here. The y was 7. The x was 5. I made it as a fraction because I'm going to be multiplying by a fraction. I noticed right here, though, that my cross reduction is going to be nice and easy because 5 goes into both of those once. Let's take care of that now. That's going to be 4 times 1 is 4. 1 times 1 is 1. So it's just going to be a 4. 7 equals 4 plus b. Now I'm just going to subtract the 4 from both sides of the equation to isolate b. Subtract 4, subtract 4. I'm going to get b equals 3. So that gives me the whole equation of y equals 4/5 x plus, now I know that b equals 3. So that is my final answer. Y equals 4/5 x plus 3. The next example, they want us making predictions. You can use an equation of a linear relationship to predict a value between data points that you already know. So we have this taxi ride. The graph shows the cost of a taxi ride. of different distances. Predict the cost of a taxi ride that covers a distance of 6.5 miles. So these are my miles. This is the cost. It looks like there's some initial fee just for getting the taxi cab, somewhere between $2 and $4. It might be exactly $3. It might be $3 and change. So I'll work out the math to figure out exactly what it is to be sure. At $6.50, somewhere in here is what my cost will be. Hard to tell though, because it's all in that in-between range, so I'm not positive. So I'll do all the math to figure it out. It will be consistent and linear, so I know I can use my tools in my tool belt of y equals mx plus b and my slope formula, which they have already started you on right there. Choosing 2 points, they gave us 2 points, which is helpful because it was hard to tell where exactly these are. So 2 on the x, turn and go 7 on the y was this one. 6 on the x, turn and go to 15 on the y is that one. So we'll use those. I'll write them up and down though, because the way we've been doing those is this way. Our brains are getting used to it this way. Let's use what our brains are used to. First choice, second choice. Perfect. All right, we're going to plug it into the equation, which they've done for us already. M equals y2 minus y1 over x2 minus x1. That is 15 minus 7 for my y2 minus y1. And then it will be 6 minus 2 for my x2 minus x1. Oops, that's a 2, not a 1. Be careful, Miss Sanchez. Subtract. That's 8, and that is 4. 8 divided by 4 is 2. So my slope m is 2, which they got there. Y equals 2x plus b. What I'd like to do is plug in an x and a y coordinate from any of these and then solve for b so I know exactly what the y-intercept is, because it's, like I said, it's hard to tell. It probably is 3, but what if it's $3.25? $3.25. It's hard to tell exactly. So I'm just going to go ahead and work out the numbers and use the simplest ones. That's x, that's y. Plug them in. We'll have y be 7, 2 times x, which in this case will be 2, plus b. Now I just solve for that. 7 equals 2 times 2, which is 4, plus b. And then isolate the variable. It's hanging out with a positive 4. Do the inverse or the opposite. Subtract 4. That cancels. That gives me b equals 3. So it was, in fact, 3 exactly. My equation is y equals, we had solved for the slope m right here, 2x plus, we solve for the y-intercept, 3, and there is our answer. In this circumstance, 6.5 miles. Miles is our x, so I would go ahead and solve now for that. I would say, okay, let me get a different color here. If I'm going 6.5 miles, then $2 for every 6.5 miles I go, plus the $3 initial fee. How much is that going to cost me overall? 6.5 and 6.5, so 6.5 times 2 is going to be 12. It's going to be 13 plus 3, and then 13 plus 3 is 16. So my taxi ride will be $16. The last section of this lesson is just talking about how bivariate data is two paired variables, x, y. If they are lined up and constant, then you're going to get a straight line. So if you have the rate of change that stays constant, you're going to get a straight line. If you have your rate of change that is different most of the time, or a lot of the times, or any of the times, you're going to have something that is not constant. So it's not going to be a straight line. So that's what they're going to show us here. So if we take the amount of years and the amount of investment in option A and in option B, so we have Andrew having two options in which he invests $200. Option A earns simple interest of 5%, while option B earns interest of 5% compounded annually, meaning he also earns interest on the interest he earned last year as well. So the table shows the amount of investment of both options over 20 years. The graph the data and describe the difference between the two graphs. So we would go for option A. Let's do that in red. Option A would be 0 on the X, turn and go 200 on the Y, so right there. Then 5 on the X, turn and go 250 on the Y, right there. Then we're going 10 on the X, turn and go 300 on the Y, there. 15 on the X, turn, go 350 on the Y, there. And 20 on the X, turn and go 350 on the Y, there. And then I would draw my line, and that's a constant rate of change going on there. How can I prove that it's a constant rate of change? Well, if I take each of these points here, I'm doing this minus this, y2 minus y1, and I'm sorry, y2 minus y1 and x2 minus x1 here, and I would get 10. Then if I do it again with these points, y2 minus y1, these are these points right here, by the way, 300 minus 250 over 10 minus 5, calculate, calculate, calculate. By the way, you're going to get 10. And if I do 350 minus 300 and over 15 minus 10, by the way, you're going to get 10. I get the same rate of change every time, so it is constant. So the graph of option A shows a linear relationship, a line. Okay, let's look at option B now. I'll use blue for this one. 0 on the X, turn and go 200 on the Y, so same starting point. All right. 5 on the X, turn, go 255.26 on the Y. Okay, well, just above 250, so right, almost in the same spot, but just slightly above. Now I'm doing 10 on the X, 325.78 on the Y. Okay, 10 on the X, 325, it's slightly above that line there. 15 on the X, 415 on the Y, so 15 on the X, 415 on the Y, I don't know, around here-ish. And then 20 on the X, 530 on the Y. 20 on the X, 530 is up here. And if I put a ruler along that, you would see it's not going to go on there. It's going in a curve, which is good for Andrew and his money making. It's going up faster than the other one, but it is not a constant rate of change because he's getting a little more money each time. So if you see a curve going on, then it's nonlinear, and you could even write that over here, nonlinear. If it's hard to tell and you have to check, you can use the equation to do that. Let's use the points. They did 255.26 minus 200. That was these y2 minus y1 and x2 minus x1. And when you calculate that out, you are going to get 10.5. Then you would do the same, 325.78 for the next set of points, minus 255.26 over 10 minus 5. And you would end up with 14.7. You would use a calculator for that so that it doesn't take you a long time to do it. 415.79, that's that one, minus 325.78, that's that one, over 15, that one, minus 10, that one. And when you calculate it out on the calculator, you end up with 18.0, or just 18. Notice these are not the same rate of change like it was over here, so they are not constant, and that would mean they are nonlinear. So really all this is trying to get you to see is if your rate of change is constant, you're going to get a straight line. If the rate of change is not constant, then you're not going to get a straight line. You're going to get something else. So that's what this whole section is trying to help your brain make a connection to. So otherwise, this lesson is really just dealing with a lot of the same stuff you've been working on. You're going to be experts at this super soon, if you're not already.